Hello, everyone. Welcome to Cloud Native Live, where we dive into the code behind Cloud Native. I'm Annie Tavastro, and I'm a CNCF ambassador as well as I lead marketing at Vision, and I will be your host tonight. So, every week we bring a new set of presenters to showcase how to work with cloud native technologies. They will build things, they will break things, and they will answer all of your questions. So, you can join us every Wednesday or Tuesday to watch live. And this week we have two amazing speakers, Kevin and Saad, here with us to talk about making VMs a first-class citizen in Kubernetes with KubeVirt. And as always, this is an official live stream of the CNCF, and as such, it is subject to the CNCF Code of Conduct. So please do not add anything to the chat or questions that would be in violation of that Code of Conduct. Basically, please be respectful of all of your fellow participants as well as presenters. With that done, I'll hand it over to our speakers to kick off today's presentation.
Thank you, Annie, and thank you everyone for joining us today on our webinar, KubeVirt, Making VMs a First-Class Citizen in Kubernetes. So my name is Saad Malik, and I'm the CTO here at Spectra Cloud, where we focus on Kubernetes management. And joining me is Kevin Rubik, the principal architect of Spectra Cloud. Kevin?
Hi, welcome all.
So this webinar is not intended to be a deep dive into all the advanced use cases of KubeVirt, but rather more of a basic introduction into the common operations and workflows for end users. We'll start with a few slides about KubeVirt technologies and then transition to the main event for Kevin to do the demo. After the demo, we'll jump into the Q&A section. So before we talk about KubeVirt, why are we doing VM management on Kubernetes? So even though we're seeing a massive adoption of containers-based workloads, the reality is that VMs are here to stay. For most organizations, refactoring all of their existing applications to containers is a significant amount of effort. Even today, if you look at the number of VMs running on VMware, it's over 85 million. And that number is only going to grow over the next few years. At the same time, many organizations are expressing concerns with the whole uncertainty around the Broadcom and VMware acquisitions. So most of these organizations are also looking at alternative hypervisors, just hedging their bets and de-risking their operations. And there's also additional benefits and potentially saving on some of the more expensive hypervisor costs. However, for me, I think one of the biggest advantages of running the hypervisor inside of Kubernetes it's that your Kubernetes footprint is already expanding. Your platform engineering teams, your ops teams are already learning how to use Kubernetes and managing the infrastructure. And if that's the case, why not have the same platform manage both your container-based workloads and your virtualized workloads? One, all of the training and support and operations are unified. And two, as your workloads over time do migrate towards containers, as you start refactoring your applications, it's the same shared infrastructure that you're using. There's no additional hardware cost that you to add into the picture. Now, looking at the technology behind the scenes, so KubeVirt is what provides VM management. It brings the Kubernetes-style APIs and manifests to drive both provisioning and management of virtual machines using simple resources. The technology has been started in 2017 by Red Hat, but was quickly adopted by CNCF as an incubating project in 2019. The underlying hypervisor is a KVM, but KubeVirt does leverage a technology called libvirt, which acts like an abstraction layer between different hypervisors. By the way, OpenStack, the OpenStack platform itself is also built using KVM and libvirt. So the technology has been mature for many, many years. Some of the really cool capabilities that KubeVirt provides as powerful hypervisor capabilities, one, not only does it help provision the state of the machines, but it also automatically restarts VMs when they crash. They enforce the VM configurations, everything from your CPUs to your RAM, networking, storage, and then of course, many different networking options. You are able to, for quick POCs, a quick environment, use the pod networks using popular CNIs like Calico and Cilium, and we'll get a little bit more into the details of that. But you can also leverage multis for more advanced configurations, whether you're exposing direct VLANs or bondings to your VMs directly. So looking at a little bit of the architecture of KubeVirt, users interface, using kubectl or the KNS or favorite tool with the Kubernetes API server. From here, they'll essentially provision what's called a virtual machine or virtual machine instance. There is a controller running here called the Virt controller, which essentially looks at the VMI and will launch an actual pod called the Virt launcher. So the pod gets scheduled to a node, and then the Virt launcher will specify to the VMI that, hey, the pod for Virt launcher is on node A. There is another control component called a Virt handler that will look for that VMI and when the node is updated. And once it sees that a pod has been scheduled to its same node, it will directly communicate with a Virt launcher to create a domain in libvirt. And domain essentially is creating that actual that KVM instance. Now, all the operations are of course managed directly by this libvirt and this Virt handler directly on the node until the time when the user says delete the actual VMI object, in which case a reverse operation happens. A deprovisioning happens of the domain, and then the pod itself is fully killed. Now, just one last aspect before we jump into Kevin. What does it take to run KubeVirt? Like, what does the entire stack look like? Well, you have to obviously start with some physical bare metal boxes. These servers become part of the underlying host clusters. Now, the first question we ask is, who manages the life cycles of these servers? There are many ways of orchestrating bare metal servers. One of the more popular projects is Canonical MAS, which is a bare metal management interface. And Canonical MAS allows you to provision and manage the lifecycle of bare metal machines like a private cloud. If you have a small KubeVirt cluster, you don't need a big data center use case or self-provision capabilities. There is an open source project called Kairos that provides tamper-proof, immutable operating systems that you can install onto these boxes for Ubuntu, Fedora, SUSE, any operating system that you may have. Once you have the actual bare metal boxes, you obviously need storage. Storage comes in two different flavors. You may have a software-defined networking solution, a commercial product like Portworx or Rook-Ceph, and obviously there are direct access capabilities with storage array networks, whether you're using flash arrays or NetApps or Dell EMCs. On the networking side, there are many different CNIs. By the way, this is just a representation version. There are many different choices you can do, whether you go with Calico or Cilium. Again, like I mentioned, if you do have more advanced networking requirements, exposing different VLANs, you can use a product called Multis. You go ahead and provision Kubernetes on top of it. Obviously, you have to install a KubeVirt piece. For monitoring, you can use something like Prometheus and Grafana. Backup, you have a couple of different solutions like Valera or Trilio. And then once the cluster is up, you can provision your different namespaces, provision your containerized applications, along with your virtualized VMs. And then the last slide is just some specific requirements relating to KubeVirt. You do need a Kubernetes cluster that is 117 or later. The host nodes ideally are running bare metal with virtualization support from the BIOS or firmware passed directly down in. If you are testing KubeVirt, whether on a private data center like VMware or on a public cloud, you can also enable emulation support. For storage, if you're just looking to provision virtual machines on individual nodes without any live migration support, you can have various regular read-only once or read-write once kind of volumes. But if you do need ability to live migrate VMs across multiple nodes, then you do need a CSA driver with read-write many capabilities. And again, for networking, keeping things simple, you can use pod network. But if you have more advanced use cases through VLANs, you can use Multis. So Kevin, what are we going to be seeing in the demo today, and what does the environment look like?
Yeah, thank you, Saad. So the environment that we have to work with today actually looks like this. So let's see, we lost the slide there, so let's get it back up here. It's a number of bare metal nodes. We have one control plane node and 5 worker nodes, all deployed by Canonical MAS, on top of which we are running Kubernetes 126. Then in this particular environment, we're using Portworx Enterprise to provide a distributed storage solution, Cilium for pod overlay networking, so that runs on top of here. We have an additional NIC in these machines that give us access to particular VLANs in the network. So I can show putting a VM directly on one of the VLANs, for which we use Multis. And then we have a couple of regular components like MetalLB and NGI next to provide load balancing and ingress services on a bare metal cluster, which KubeVirt and Prometheus Grafana can then use. And then using KubeVirt, we can run virtual machines. And of course, we have this side-by-side of containers and virtual machines running next to each other. So what I'll show is the steps of creating first an ephemeral virtual machine. This is what you often see in other demos. And then what we can do to put such a virtual machine on an existing VLAN. Then how you can create a persistent virtual machine using something called data volumes, so that the machine actually lives on a persistent volume and you can make changes to it. Then we showed live migration, and then backup and restoring via a snapshot. All right.
Well, let's get to the demo.
So all of this is available on a GitHub repo. So if you want to check out any of the manifests here, you can get it at krewijk at cncf-kubevirt. The link will be posted in the channel as well to get it there. So we have these manifests here, and let's first start at looking at what one of these things look like. So a virtual machine manifest is just a spec, similar to like an OVF definition of what the VM should look like. And it has very similar items like how many CPU cores should be in there, which disks should be part of it, what network interfaces should we use. Then there's a translation to what that means inside of Kubernetes. So that same number of CPU cores also means that we want to reserve that amount of storage capacity, and you can play with overcommitment here. The interface inside the VM, we can translate to what that is on the Kubernetes side. So in this case, we'll start by putting this container on the regular pod network, or this VM on the regular pod network as if it were any other container. And then we'll look a bit further at what it requires to put that on a VLAN. And in this case, we're just saying that the volume for this is a container disk, which means that it's not persistent. If we shut this down and start it back up, we just get the same image all over again. But it's a great way of starting a VM from a known image that is ephemeral. So it can be really useful for runners, for example. And then we can do stuff like Cloud Init, for example, to provide additional steps that automatically need to be run as the VM starts up. You can also do this via a CLI. So if you install the virtctl plugin, you can do this with like cuddle crew install virt, for example, to install this automatically. You will get this CLI, which gives you access to a lot of the common items. So, but when it comes to like creating a VM, you'll see that that is actually quite basic. You can provide some options and it will spit out a basic manifest here, but it's usually better to just use the KubeVirt guide to write the manifest directly as we have here. So let's apply this. There we go. And then we'll see inside of the cluster that we now have a virtual machine. So it got the configuration that we wanted, and it is starting. And that will create a virtual machine instance, which is another definition, which is essentially pretty much the same configuration, but now this is like desired state configuration of an instance that should actually exist in the cluster. And so if we look at pods, we now have a Virt launcher, and this is the process that actually runs QEMU to run the virtual machine with the resources allotted to it. So this pod will have these, resource limits applied to it here to specify how much can actually use from the cluster. And you can see here that network information automatically gets added to this pod depending on how we configure it. So currently this is on the pod container network. And so if we look at the VM, at the VMI, I believe, we can see that it's been given an IP address on the pod network. Pod network is 100.64.0.0/18. And so it got one here, and it's running on host AC300. If we wanted to connect to that, we could just say KubeVirt VNC, and then say we want to connect to the VMI. Actually, what was the name that we had for this? This machine right here. We want to connect to that, which is like in the namespace CNCF. And will give us some information of what to connect to. We can say that we just want proxy only. And now it's listening for this on 42121. And then I can spin up a VNC console and connect to this. Actually, I can do that. So we'll take a VNC console right here. And we can connect to, we'll adjust the, oh, it's actually not this one, it is. Yes, it is.
Yeah, and there's a quick audience question as well. Hey, I have a question. Why we need VMs in Kubernetes?
Why we need VMs in Kubernetes? Because not all workloads are easily convertible. So, for example, if you have a Postgres server, trying to containerize Postgres is actually quite a bit of work if you want to do that reliably, since you'd have to do like a multi-container distributed database kind of setup. And for a lot of workloads, it might actually be not really worth it doing all that refactoring of the application for all parts of the application. And so it can be really useful if you can take some parts of the applications that are hard to containerize, bring them into the Kubernetes cluster, and then run them as a regular VM, still have vMotion capabilities, and just hold off on the conversion of that particular piece while you work on other components of an applications that are much easier to containerize. So you can move the whole thing forward and not have to be blocked on these kinds of things. So that's why it makes sense to do.
And I would just add that KubeVirt is the cloud native orchestration, the cloud native approach to being able to manage virtualization with a complete hypervisor built as a single package. And obviously it can run in any environment, whether it's bare metal or cloud or data center, even though ideally it runs for bare metal so that you can get maximum performance.
Great. And they had an extra question as well. What's the difference between these VMs and work nodes?
So the worker nodes are the bare metal nodes that are actually running the cluster itself. The virtualized VM workloads run as containerized pods inside of the cluster, right? So you might have, I'm just throwing out an example, 10 worker nodes that are comprised of the bare metal nodes. And maybe, Kevin, you can show the nodes here in your KNS. So notice that Kevin's environment has 5 worker nodes and 1 control plane node. But if you look at all virtual machines across all namespaces, you might have many different VM, yeah. Yo.
Oh, okay. And all. So if we just show all, now we see different VMs across different namespaces.
Yeah. Can we run non-Linux kernel VMs? Anything that KVM supports, including Windows, Linux, FreeBSD, they're all supported on the KVM.
So you see Windows running here, different Ubuntu versions. Yeah. So let's see, I just stopped this particular VM, so we can see the status is stopped. Did that by adjusting the run state to false here. And of course, in GUI tools, you would have like buttons to do that for you. And let's take a look at what happens if we want to put this on a VLAN so that it is externally accessible or easily externally accessible. That's same manifest, but now what we're saying here is we want to use a bridge interface inside of the VM, and we want to bridge it to a Multus network, which is a network called, in this case, VLAN 0. So if we take a look inside the cluster and look for network attachment definitions, then for the CNCF webinar, these are per namespace, so it can be really useful to actually lock this down on a per namespace level. We can say that we have something called VLAN 0, which will give access to, in this case, just the native VLAN. But of course, you can put different VLAN IDs here. I think we have like a different one here, which will give access to VLAN 128, for example. And then when you associate it to such a network name, it will make that VM accessible on that particular VLAN. So let's apply this manifest, which will update our VM. There we go. To now be linked to, there we go. So now it is linked to the Multis network, and we will start it back up again. And so we'll set, oh, it is running is already true, so that's great. So we'll see in the virtual machine instance that now this is running again, and it will take a little bit longer, and we'll see something that's similar to this, where it will get an IP address that is actually on VLAN 130, which is the native VLAN for this particular port. So VLAN 0 gets translated to 130 in this particular port that the machine is on. And it gets an IP address directly on that network. And so this can be used to make sure that VMs can be migrated from an existing solution like Hyper-V, VMware, onto a Kubernetes-based virtualization cluster without changing anything in the VM. You just convert the VM, you bring it here, it can keep its same name, IP address, everything, and run as usual. All right, so once we have that, let's take a look at let me create this first. And then let's take a look at what this VM is. So this is a different one where we see something called a data volume template. And so here we specify that we don't want to run this VM ephemerally. We want to grab the same container image that we had for the other one, but push that onto a read-write many persistent volume of a certain size, a size that we can control, and then run the VM from that volume. So everything else here is the same. And instead of a container disk, now it says a data volume here with the name of that template. And so what happens is that inside the cluster, let's limit it to our webinar namespace, just to make it a little bit easier. There's now a PVC for the data volume. We'll see two created. There's a scratch DV here to initially link the container volume on. And then there was an import process that just already ran that copied over all the data into this persistent volume. And now the pod that gets created with this, let's see, actually the VMI that will get created in a moment will then be linked to that persistent volume. So the container disk one that we have is not linked to any persistent volume here, but the, here we go, the virtual machine instance that is now tied to this data volume is automatically linked to, let's see where we are, to a persistent volume claim. And so this automatically gets translated. And it will see if that data volume exists. And if it doesn't, it imports the data and gives it to that VM. If it already exists, it gives that existing PVC to the VM so that everything stays persistent. Now we have another VM here, which is, again, on the pod network, but this is fully persistent, and you can save state to this. So once we have something that we actually care about, we want to make sure that we don't lose it when we upgrade Kubernetes or a node goes down for maintenance, for example. We want to be able to move those workloads around. Now, let me exit out of this. There we go. So what we can do is we can do live migration, and we'll do that for the second persistent VM. And so what this manifest is it's just a virtual instance migration resource that tells Kubernetes or KubeVirt to migrate a VM of this name in this way, namespace. And so if we apply this manifest, then we can see that now another pod for this launcher is started on a different node, on the 101. And we are migrating this information over. And we can actually see that by looking at virtual machine instance migration objects. And it's already happened. Of course, this is a small VM, so this happens quickly. But you can actually track that data here. And there's a lot of technology that KubeVirt will automatically do for you to make sure that these live migrations can cope with like bigger workloads. So by default,
there's an audience question. So Deepak asks, what would be the reason some of these companies still use VM rather than containers?
Because it's the same reason that we still have bare metal servers, that we still have mainframes here and there. In reality, what happens is that new technology just gets added and it becomes like 10 times more ubiquitous. But the previous iteration of that technology typically never fully goes away. And so there will always be, or for a long time, there will still be VMs around that are running some really important workloads. And it will be very difficult to get rid of all of them.
Yeah, and I think just another data point to add is most new organizations obviously will start new projects, greenfield applications, all containerized or serverless. But there are many legacy organizations that have applications for many, many years. That data point, VMware alone has 85 million workloads running on VMs, and they're estimating by 2025 that number to be close to 120 million. So we're still going to see an increase of VM-based workloads, whether it's different type of load balancers or firewalls. Somebody put a comment about pfSense, as a different solution. There are appliances that customers or vendors are providing to customers as virtual appliances. Many of them are still virtualized based. So we're still going to see adoption of VM technologies, even though over time it is going to start slowing down when containers and serverless become ubiquitous everywhere.
Yep. You need that bridge between the old and the new.
Exactly.
And so that's why it's important to make sure that all of the core capabilities of running VMs at scale can be done in Kubernetes, like live migration, like snapshot capabilities, so that you can confidently move those workloads over, because there's definitely benefits on doing all of the same inside of a Kubernetes cluster, because these workloads here, I have now control over how I publish this. So this could be a VM that's running like it is a container inside of the pod network. So it's fully shielded from the network. It runs in an overlay. There's no attack surface until I create a Kubernetes service to expose one or more of the ports on that VM, for example. And then I can control how that happens, whether that's via cluster IP so that other workloads in my cluster have access, or via a load balancer so that they can be externally accessed, or even as an entire VLAN so that the whole VM can be accessed, depending on how far you are in your migration towards a Kubernetes operations process. So it gives you a lot of flexibility of creating those hybrid applications without having to stitch your legacy VM platform and your new cloud-native Kubernetes platform together.
Yeah, and the other really big advantage, just think about the 1,800 plus integrations available in the CNCF landscape. Everything from your logging, your monitoring, your ingress solutions. All of these technologies, for most part, will work not only with container-based technologies, but also with virtualization, with KubeVirt itself. So the example, I don't know if, Kevin, you're going to show later, maybe a backup solution or Prometheus example, but all these different capabilities work the exact same way, even for virtualized workloads.
Indeed. Yeah. And so, where's my...
And there was an extra audience question. I think after that, we can get back to the demo, the regular program. Okay, here I have another question. Is that VMs in Kubernetes meaning that nested virtualization or not?
No, this VM is actually running on bare metal, so directly on the hypervisor. What happens is that essentially all of the containers are running natively as containerized processes on the Linux host. It's Ubuntu running on the bare metal machine. And then there's KVM as a kernel module that provides hypervisor capabilities, and all the VMs run as that. So it's no nested virtualization. All that this launcher does is it just kicks off the QEMU process of triggering the hypervisor to spin up a VM, but there's no nested virtualization happening here.
Yeah. For testing, if you wanted to test on a cloud, or if you wanted to test on VMware or another private cloud like OpenStack, you can, of course, launch Kubernetes clusters on those VM technologies, and you can do nested virtualization, even though it's not recommended in production.
Yeah, yeah. And KubeVirt provides an emulation mode to like run it without nested virtualization, but that would be even slower. Yeah. All right. Let's look at two last steps, snapshots and snapshot restores. So if we wanted to make a snapshot of a VM before we do some maintenance to it, for example, we can ask Kubernetes to take a snapshot of the machine. This natively integrates with the CSI. So it requires that the CSI snapshotter is enabled, which is when we provide this for customers, something that we automatically enable. And then the CSI will do the heavy lifting of creating the snapshot, but it will give you an easy to use resource called a VM snapshot to maintain the state that you want. So if we do this, we apply, then we can see that now a VM snapshot exists of this VM, this persistent VM that we have. And that will also show if we go into a volume snapshot as a snapshot of the underlying PVC. So all of those like dependencies automatically get resolved, and it finds that it needs to use the Portworx snapshot class to make a snapshot of the PVC that belongs to this particular VM. In this case, we just have the snapshot. But what happens if we restore this snapshot? So first, to be able to do that, we have to shut down the VM. So we will take our VM and edit it and set it to a run state of false. Shut it down. There we go. So there it stops. Actually, it takes a little bit longer for it fully stops because the launcher has to terminate. But we can already ask this to now start restoring the snapshot. And this looks very similar. It's a VM restore, which will then, again, look for the VM, look for all of the persistent volumes that are associated with that VM, and then we return it to the state of the snapshot that we choose. So this will be this snapshot. So in the snapshot that we made here, we gave it snap VM2 as a name, and that is also the snap that we call out here to restore. So if we apply this one, then what we'll see is now we have a VM restore object, which has completed. So again, because this offloads to the storage integration directly, this is really quick to do. And what we'll see is that if we now take a look at the virtual machine, and let's set it to start. There. What we'll see is that the data volume has now changed to a restore. So a new PVC has been created. If we look for PVCs here, we see that our original data volume is still here, which was the state before we restored the snapshot. So you still have the ability to go back to that as well. And now a snapshot has been restored, creating a new PVC with the content of this, that particular volume when the snapshot was created. And the virtual machine is now connected to this particular PVC. And so here we go. We have our new pod here, and we can see that this is now linked to our restore PVC, which has the content of this snapshot that we restored.
Great, and there's a few audience questions as well. So Sayan asks, is the KubeVirt support horizontal / vertical scaling?
Let's see. It depends a little bit on the technology used. So for example, if you use Portworx, then it can do automatic scaling of the underlying persistent volumes if they start to run out of space. Many of the CSIs will provide that kind of capability. I don't know, Saad, if you've seen it.
Yeah, so KubeVirt does for the virtualized workload. So you're right, for the CSI and storage, you could do horizontal scaling. But for the VMs themselves, there is a manifest resource type called a virtual machine instance replica set. Essentially, you can think of it like a deployment or an actual replica set that we're all used to in containers. And you are able to attach a horizontal pod autoscaler to that virtual machine instance replica set, so you can drive it based on CPU and memory, and it'll do automatically horizontal scaling. Now, it's really interesting you asked about vertical scaling, because Kubernetes 1.27 just added support for being able to hot plug and change your CPU and your memory requirements on a running pod without having to shut it down. KubeVirt just yesterday implemented support for doing hot plugging of CPU and memory. So the next release of KubeVirt will see also vertical autoscaling for live VMs as well.
Yeah, or at least the ability to adjust your VM to a new spec, and then probably you'll see automatic vertical scaling implemented after that. Yes.
Yeah.
Great. And then there was another question. Is there any integration between KubeVirt and Ansible, for example, to manage the inventory?
Yep. Ansible does have, I mean, this KubeVirt is a very mature product, obviously with 7 years behind in the making. There is an Ansible module called KubeVirt VM that allows you to manage all the lifecycle aspects, from provisioning VMs to day 2 operations to deleting VMs. So absolutely, you can use Ansible for that.
Yeah, essentially that just makes like these steps more straightforward to do. When you're talking about managing the software inside of the VM itself, you're still free to use whatever traditional OS management and software management tool you want to use inside of that. Ansible, Puppet, Chef, that kind of options.
Great. And then there was another question from Deepak. What would happen if any alternative that comes to Kubernetes? What would these companies do to continue with the Kubernetes or get into a new technology? Is it always scalable to change tech every time?
Well, once you've converted this, essentially you've converted it to KVM. And KVM is essentially used in all of the major cloud platforms that are not Azure or what's the other one?
Hyper-V and Zen is the other one.
Yeah.
Right?
So everything else, Amazon, Google, Nutanix, they are all running versions of KVM. So if some other container orchestrator were to come along, then yes, you might have to move your VMs to that other platform, but it's very, very likely that that hypervisor will be KVM as well, because the container orchestration doesn't really have anything to do with hypervising. And so that technology will probably just stay the same.
Cool. And then there was a last question so far from Ashkan. Would it be possible device plugin be effectively utilized within KubeVirt VM to enable integration and management of GPU resources?
Yep, that actually is natively supported. So if you want to pass through a GPU or other hardware devices for that matter, that is something that this totally supports.
Yeah, device pass-throughs, absolutely.
Great.
All right, that concludes my demo.
Cool, let me go back to sharing my screen. One moment, please.
Yeah, perfect.
Cool. Any other questions from the audience? I think there's a lot of fantastic questions.
There's been a lot for sure.
Yeah.
So far, I don't see anything new there, but I have questions as well. Do you have anything else to finally say in the thank you portion, or should I get to my questions?
I mean, I can just, for my closing comments, I would just want to say that I think there's lots of advantages to running virtualization in Kubernetes, right? Obviously, being able to use a cloud-native approach and framework. Many of the capabilities that Kubernetes provides, from service discovery to auto healing, secret passing, these are natively supported, whether it's through containers or for virtualized workloads. And then, like we mentioned, many of the integrations that exist in the CNCF landscape will continue to add value for both virtualized workloads and container workloads.
Good. And if the audience has any questions, please ask them now. Now is the perfect time to ask them, so go ahead and type away. But while we see if the audience types any questions in, I would like to ask you, is there any prerequisites for running virtual machines on Kubernetes?
Kevin, you want to talk about storage networking?
Yes, the biggest is that if you want a live migration, which you probably want, you don't want VMs to be stuck on a single node. You must use a storage solution that supports read-write many persistent volumes. They can be block or file system, but in most cases, it has to be a file system type to have read-write many support, depending on the storage solution that you use. That is, I think, the big one. And then on the networking side, it is just recommended to make sure that you have a good network design that separates out data from management and gives enough NICs. We would recommend at least 4 NIC ports to separate out the different streams reliably, so that you get a proper, reliable cluster to work with.
Great. And then there's a question from the audience. Can we create Android OS VM via KubeVirt?
I think the question there is basically ARM64 support. I think that is under development, but not yet available.
Okay, so coming at some point. So also from my side, can I run KubeVirt on any Kubernetes cluster in any cloud or only in certain environments?
Well, the challenge is that if you run KubeVirt in the cloud providers typically don't give you access to the low-level networking. And so it might be difficult to publish the VMs directly on some of the virtual subnets that you have, as that technology tends to conflict. So if you run it on the cloud, it's recommended to keep the VMs running in pod networks, in overlays, and then publish them as services. If you want to go further and really expose VMs directly on VLANs as you would do in your own data center, we would recommend running your own bare metal hardware cluster.
Great. And then there's a question from Jesus. Can snapshots be exported? Which format? S3 supported?
The backup technologies typically do that. So if you use, it kind of depends. So if you use Velero, then what happens is that the backups get converted into a CSI snapshot. And then it depends on the snapshot provider setup of where these go. So if you use a typical Velero layout with, for example, Portworx Enterprise, the quick setup is to have a snapshot and it gets stored inside of the existing Portworx storage. But you can also set up Portworx Cloud Snaps, which will then actually move those snapshots off to either S3 or something like Pure Array FlashBlades. Any NFS or S3 compatible storage solution allows you to move that off. If you use something like Twilio, then you can do all of that in one shot, where it will take a snapshot of the VM to get at a readable copy of the data while the VM continues, and then it will offload the snapshot data to S3 or NFS location of choice, and then you can restore from there. So it's typically the backup solutions and the storage solutions that provide options there.
Good. And then there's an audience question from T-Back, which is pretty much a big question, or a large one, I think. What would the role of AI be in Kubernetes in the future, or maybe in DevOps or cloud? Any thoughts there?
Yeah, it's a great question. Obviously, we're seeing generative AI is taking over the world. Every single person is using it. I feel there's going to be 2 different aspects. One is going to be in terms of the workloads, being able to make it easy to develop workloads, optimize and run and place them. But the other aspect is at the infrastructure level, being able to provide intelligent placement across different nodes, being able to schedule different workloads across different clusters without a human intervening and specifying, run my workloads. It's going to be more AI driven automatically. I think there's going to be a lot more work we're going to see, depending on how and which stack of the area people are looking at.
Good. And then from my side, a question came to mind. Is there something like vMotion for KubeVirt?
Yes, that's live migration. We just showed that. So yes, you can migrate your VMs without taking them down from node to node.
Good.
And then you can trigger the live migration, not just for individual VMs, but like Kevin showed, you're also able to evict an exact node itself. All the VMs on that will essentially live migrate over to other nodes.
Yeah, KubeVirt has a resource that you can configure, and you can set an evict strategy. And what we do by default is we set that to live migrate, so that whenever Kubernetes decides that it needs to evict a virtual machine, it automatically converts that to a vMotion to a different host.
Good. I have a few more questions in mind, but if the audience has any questions, please feel free to drop them in and we can get to them. So from my side, is there something like DRS for KubeVirt?
There is. So there is something called the descheduler, which is an existing project for Kubernetes that helps you evict workloads from nodes and let Kubernetes reschedule them on other nodes that are not as busy. And it has built-in logic on like how busy a node has to be before that eviction process happens. This can be leveraged for KubeVirt because it essentially does the same thing. You just configure it the way that you want, what the thresholds are for node utilization and underutilization, and then it will automatically decide to evict certain VMs from nodes, which will cause a live migration to nodes that are not as busy, and that way you have your essentially DRS at home.
Good. Final question from my side. So also audience members, if you have any questions, please go ahead. How does networking work for virtual machines on Kubernetes clusters?
So the quick way is there are two options. One is running a VM as if it were a container workload. And so it just shows up as another pod inside the containers on the regular CNI overlay network that you typically use, like that Calico or Cilium provides. And then like any container on Kubernetes, you don't directly have access to that particular pod, but you can publish access to parts of it using Kubernetes services. And so you can create a service and then via metal LB, give it an external load balanced address, for example. And then whatever particular port you decided to publish, that port lands in the VM and you can access that. So if that were like port 22, you get SSH access. If it was port 5432, you get Postgres DB access if that's running on the VM. And then a second option is to use something like Multis, which allows you to define additional networks that could be direct VLAN access, for example. And that's what we showed in the demo here, where you can give a VM access to a specific VLAN, and then Multis will give it a different network configuration that lands it directly onto that VLAN. And then it can get either an IP address there, or you can statically configure it. And then it will be running just as if it were plugged in directly on the network, or if it was like similar to a VMware cluster, where you give it a network, a port group that is in a similar VLAN.
Good. Final call for questions for now. If you have anything, please send them in. And then Jesus asked, can VM endpoint be used as targets of Kubernetes load balancer service?
Yeah. So you can just use regular service resources, and it works just the way that you would expect to.
Okay, great. So if anyone doesn't have any questions, do you have any final words, notes, Saad or Kevin?
Yeah, absolutely. So I think everyone, thank you for attending the webinar. If you want to see and play around with all of Kevin's workflows, his link is available directly on this page here. I believe, Anna, you also published that link onto the chat. Kevin does have a webinar next week or in 2 weeks on bare metal Kubernetes with Maz. That's also going to be done with Kevin and an expert from Canonical Maz. So please do scan this QR code if you're interested in attending there. If you're more interested in about bare metal clusters, how to provision them, how to maintain them, please do take a look at our blogs. And also Spectre Cloud is invested in this area for managing a complete stack, everything from bare metals to virtualized workloads. If you have any questions or if you have any thoughts or comments, feel free to reach out to Kevin or me on LinkedIn. We're very happy to help answer any questions, whether it's bare metal Kubernetes, whether it's KubeVirt or anything else in general.
Absolutely.
Perfect. Those were really good ending words for today. But as always, from my side as well, thank you everyone for joining the latest episode of Cloud Native Live. It was great to have a session about making VMs a first-class citizen in Kubernetes with KubeVirt. We also really love the interaction and questions from the audience. Really lovely to always see that. And we bring you the latest cloud native code every Wednesday or Tuesdays. And in the coming weeks, we have more great sessions coming up, so stay tuned for those. Thank you for joining us today, and see you all next